Hello! Welcome to this video on cognition. In this video, we're going to address two aspects of cognition, and these include mental representations and also judgment and reasoning. Before we begin, let's just remind ourselves that we use cognition synonymously with the word thinking. Okay, let's begin by understanding something about mental representations. Let's start with this definition of mental representation as a hypothetical internal cognitive symbol that corresponds to external reality. As you're listening to this video, I hope you'll always be careful to distinguish between two often confused categories of vocabulary. One category is the category of brain states, and the other category is that of mental states. And in everyday life, sometimes people use these interchangeably. I'd like to draw a fairly sharp distinction here, though, that I hope will make sense for you throughout this video and as you move on to your further study of psychology. When we talk about brain states, we're talking about those kinds of things that can be measured anatomically or physiologically. And these would include such things as the action potentials or firing rates of individual neurons, or synchronized neural firing across populations of neurons, or electroencephalograph recordings, EEG recordings. Bold signals. You might recall that BOLD stands for blood oxygen level dependent signals, and these are the signals that are picked up in an fMRI experiment. Other kinds of brain imaging experiments might track something called RCBF, or regional cerebral blood flow. These are all anatomically measured, they are physiologically measured, and we want to contrast this category with a mentalistic category. Here we have a list of mental states, and these include such things as sensations and perceptions, attention, memories, thinking, reasoning, mental imagery, and that could be audio imagery or visual imagery, and emotions, intentions, beliefs, and attitudes. These mental states, which some people will refer to as psychological states, arise presumably from underlying brain states. And there's an important correspondence that goes on between these two levels of analysis, but they are in fact distinct levels of analysis. And sometimes when we're speaking of one, we might accidentally slip into the language of the other, and we want to caution against that. Okay, with that caution duly noted, why don't we move on to talk a little bit more about representations. Psychologists who study mental representations often distinguish between two broad categories of representation. One is called the analogical representation, and the other is called the symbolic representation. Let's take a look at each in turn. We can define analogical representation as a symbol that physically resembles its referent, and that's where our emphasis is, on the physical resemblance. So let's take a couple of examples. Here we have a very simple road sign, and what this road sign is conveying to whoever might be looking at it is that the upcoming road is going to bend eventually to the right. It's not going to continue straight. It's not going to go to the left. This could be interpreted by just about anyone, regardless of what language they speak. Likewise, over here, we have some symbols that might be indicating which particular rooms are available for men or which rooms are available for women. Many people, regardless of their language, would recognize this symbol as being that of a man and this symbol as being that of a woman. So we have a physical resemblance between this particular symbol and its referent, the thing in the world, if I can be so informal, to which it is referring, whether that happens to be a person or whether that happens to be a road. There are entire literary constructs that fall into the category of analogical representation. You might know this as onomatopoeia, and some examples of onomatopoeia would include clickety-clack, or meow, or moo, woof, oink, splat, and ka-ching. Each of these words or phrases sounds like what it is referring to. We very definitely get an idea that we're hearing a dog here. And the word woof sounds very much like the bark that a dog would make. Other examples of analogical representation include certain Roman numerals. So for example, this is a Roman numeral 1, this is a 2, and this is a 3. Importantly, this particular symbol, which is an analogical symbol, has one vertical line, and it is referring to the numerosity 1. This symbol has two vertical lines, and it refers to the numerosity 2. This one has three vertical lines, it refers to the numerosity 3. So there is a physical resemblance between the symbol and what it is referring to out there in the world. We can contrast all of these analogical representations with so-called symbolic representations, shown here. We can define these as representations that have an arbitrary correspondence between two systems. Note here that the emphasis is on the word arbitrary as opposed to physical resemblance, which is what we saw in the preceding slide. So So let's take some examples. Here we have a stop sign, and most people who are looking at this video have no trouble understanding this stop sign. But let's recognize that this sign does not physically resemble the act of stopping. It doesn't physically resemble a stopped car. And yet somehow we all recognize that this refers to the idea that a car that's approaching this sign should come to a stop. But that's an arbitrary correspondence. We've learned that. We have a societal convention that teaches us that. It could have been a different societal convention. You can imagine it could have had a different shape, and it might have been a different color, and yet a society could learn that that particular symbol means stop, but that would still be an arbitrary correspondence between the symbol itself and what it is referring to out there in the world. All of these letters that you see, many different letters here in the English alphabet. And when we pronounce them A, B, C, D, and E, and so forth on down the line, we make particular kinds of sounds. We've learned the arbitrary association between this squiggle that you and I call an A, and that squiggle that we call a B, and there are different sounds associated with those different squiggles. All of those associations between this squiggle and its corresponding sound, those are arbitrarily established. The B doesn't physically look or sound like its squiggle. It just is an arbitrary connection. Same thing here for the yield sign, just like in the stop sign. We know these symbols because we've learned the arbitrary connection. Indeed, most words, here's the word blue, or short, or inconsequential, or the phrase liberal arts college, or the word psychology. We've learned the arbitrary correspondence between these letters and what they mean out in the world. Let's return to another example now. We'll come back to Roman numerals because we saw in the preceding slide that we had a few examples of Roman numerals that were bearing a physical resemblance to their referent. Those were analogical. Those were the numbers 1, 2, and 3 in Roman numerals. Here, we now have the numeral 4 using Roman numerals, but I know that only because I learned that arbitrary association sometime when I was in grade school. Notice that we have one vertical line, and then two of these lines that have an orientation that is not vertical. And yet that particular ensemble refers to the numerosity 4. Here's an X in one symbolic system, but in the Roman numeral system it means the numerosity 10. Here's an XCV11 is what we might say in one system. In another system that turns out to be a 97. For those of us who are on the knowledge of how to construct Roman numerals, we can translate this, because we know the arbitrary system, into the number 97. But this doesn't look physically like the numerosity 97. So now we've learned an arbitrary correspondence between the symbol and what it's referring to. This is a symbolic representation. We can think about still other kinds of representations. For example, we might have imagery that might be visual imagery. You probably can close your eyes and imagine a kitchen that you knew very well as a child. You probably see it very vividly, so to speak, in your mind's eye. This is a mental representation. You can probably hear, for example, a parent's voice or a grandparent's voice. You probably have a very salient psychological experience with that if you close your eyes and try to imagine that auditory stimulus. These are different kinds of mental images, sometimes visual, sometimes auditory. Psychologists spend a lot of time looking at these kinds of representations also. Okay, let's go on to consider a particular variety of representation. Within the domain of mental images, there is a well-studied phenomena known as mental rotation. And here we have some mental rotation stimuli. In the top portion, we have some three-dimensional stimuli, and you might be able to tell that no matter how you spin this, you'll never get one of these. These, in fact, are two different objects. This is a three-dimensional case. Researchers also investigate the two-dimensional case. So here we have a shape that can be rotated, and if you'll rotate it with me in a clockwise manner, we could eventually come around to this shape. Similarly, we can take this shape and rotate it clockwise and come around to this shape. What's very, very interesting about these mental rotation studies is that we find that people often exhibit this kind of a pattern. The greater the angle through which we must rotate one image to get to the other, the greater the reaction time. It's almost as if people can't directly see that this and this are the same image. What they have to do is mentally flip this through the varying angles until they get a match to this, or flip this through the varying angles until they get a match to that. And the further they have to move it, the greater the number of degrees through which they must rotate one image to get to the next. We have longer and longer reaction times. So this would suggest that the people don't directly see that this and this are the same item, but rather that they actually have to go through this task of mentally rotating. And this, again, is evidenced by the fact that the greater the angle between these two stimuli, the greater the reaction time. It's a piece of evidence suggesting that people are actually performing a maneuver on one of these stimuli mentally to get to the next stimulus. For those of you interested in learning more about mental rotation, here's a PubMed abstract. Okay, let's move on and get away from mental representations and mental images and start to go to another domain of cognition, which we've said before is the domain of thinking, and we'll address the topic of judgment and reasoning. Some people define judgment the following way: the process of extrapolating from evidence to draw conclusions. And a pioneer on this is Daniel Kahneman. Professor Kahneman did some very important work in the domain of cognition and judgment and decision-making, known as heuristics. So let's begin to understand heuristics. We can define a heuristic as a judgment strategy that favors speed and ease over accuracy. Informally, we can think of a heuristic as a rule of thumb. It doesn't always work, but it generally works, and fortunately it works rather quickly. It's interesting to muse about two critical thinking questions. One is, why might evolution favor heuristics? Presumably, our most ancient ancestors didn't have the capacity for heuristics, and yet you and I do. Why might that have come about evolutionarily? A related question that we can ask ourselves is, given the evolutionary development of heuristics, we might ask then, how does evolution lead to stereotyping? That is, how is it that heuristics, which depend on evolution, get us to stereotyping? In general, heuristics can be advantageous, but what comes along with that, unfortunately, is some inaccuracy, including the inaccuracies that can arise from stereotyping. Okay, let's move on, and we'll consider two different kinds of heuristic. One is called the availability heuristic, and one is called the representativeness heuristic. Let's consider each in turn. The availability heuristic might be defined this way. It's a cognitive shortcut that relies on the ease of generating examples. How available is a particular example? Its function is to help us in judging frequency. On the implementation side, we can say that we use example accessibility to indicate frequency or probability. Of course, there are limitations associated with this heuristic, as there are with all heuristic. In this case, we can say specifically that errors tend to arise when availability, that's the ease of generating examples, is not correlated with the empirically observed frequencies. Okay, so some of you might be thinking, these are all very abstract ideas, we might benefit from an example or two. Okay, let's consider some examples of the availability heuristic. A question that we might ask some participants in a psychology experiment is a very straightforward question. Does the letter R occur more frequently in the first or third position of words? Interestingly, most people can more easily recall words with R first than with R third. They incorrectly conclude R first is more frequent, even though R third is actually more frequent. But because R first is more available to them, it's easier for them to generate specific examples of R first than of R third. They fool themselves into thinking, per the availability heuristic, that R first occurs more frequently. Here's another example. Are male and female students late to class equally frequently? Our answer might be skewed if we base our judgments on easily recallable male or female students. So maybe there's a particular person in your class that's late all the time, and it's only that one person, and that person happens to be, for some folks, a male, and in another class, maybe it happens to be female. Based on how easy it is for you to generate that example, you might fool yourself into thinking that one or the other of the genders is in fact more likely to be late. However, if you were to do a scientific analysis and look at gender and its relationship to lateness, you'd find that there's no relationship there whatsoever. But the availability heuristic might fool you into thinking otherwise because of the ease with which you could generate a particular example. The availability of that example will be skewing your cognition in this way. Here's one more example that might help you. And this is an example again of the availability heuristic. When people are thinking about the dangers associated with travel, people will often think that flying in an airplane is more dangerous than driving in a car. And maybe one of the reasons why they do this is that when car accidents happen, even when they're lethal, most of the time those car accidents don't make national news. By contrast, when there's an airplane accident, it almost always makes national news. And we see sometimes spectacular pictures of the horrifying plane as it's falling down to the earth. These are very salient. These are images that are very easy for us to generate in our memory, and they weigh more heavily than they should when we're trying to calculate the actual frequency of these kinds of transportation errors. Okay, so this is the availability heuristic. Let's now contrast that with a similar yet relevantly different kind of heuristic, and this is called the representative heuristic. We can define this as a cognitive shortcut that assumes each member of a category is typical of a category. That is to say that it's representative of a category. So here we're about judging categories. By contrast, back in the availability heuristic, our function was to be judging frequency. Here we're judging categories. And we can talk about its implementation. For the representativeness heuristic, we can say that we would use resemblances to indicate category membership. So we're trying to, again, figure out whether a particular example is a member of a category or not. The representativeness heuristic tends to increase with category heterogeneity. That is, as the elements within a category are more and more different from each other, then any given category member is not particularly representative of any other category member. Let's take some examples. One of the ways of thinking about the representativeness heuristic is to take the example of the so-called man whose story. And what we mean by the man whose story is the following. People will sometimes say, oh, I know a man who, and they'll fill in the blank, and they'll offer an anecdote about a particular individual that is highly misrepresentative of the category to which they are referring. So when anecdotes are offered as the justification for assigning categories, one assumes that the anecdote is typical, but it often isn't typical. Let's take a few specific examples. We can look at this picture, and we see that we have somebody who's obviously running on a track, and they obviously have a prosthetic device. Now, people who have prosthetic devices are not typically world-class athletes, as this person appears to be. And people who are world-class athletes typically do not run on prosthetic devices. Yet we can all, through this picture, say, well, I know a man who is a world-class athlete and runs on a prosthetic device. It might be the case that this is true for this particular person, but this picture does not symbolize something that is representative of either the category of Olympic athlete, nor the category of people who wear prosthetic devices. Let's take another man who case exhibited over here. For those of you who don't know, this is a comedian from many decades ago. His name was George Burns. He had a cigar as part of his shtick, part of his comedy routine when he was on stage. And he had a good long life and a good long career. He lived into his 90s. Now people might look at him and say, well, here's a person who's smoking and lives to be 90 years old. But smoking is not particularly representative of people who are in their 90s. And people who are in their 90s are not particularly representative of those who smoke. And yet here we have a man who is smoking and is in his 90s. But this picture is not particularly representative either of smokers nor of those in their 90s. If we use George Burns as an example of either people in their 90s or people who smoke, or the relationship between them, we've made an error through the representativeness heuristic. So, summing that up, heuristics are good because they're fast and they're often accurate, but occasionally they miss, and they might miss due to reasons of representativeness, or they might miss due to reasons relating to the availability or the ease with which we can generate that example mentally. Okay, there are still other kinds of cognitive errors that we can make, and these would include the confirmation bias. The confirmation bias might be defined as the tendency to be persuaded by information consistent with one's prior beliefs. So let's think about some examples here for the confirmation bias. Imagine that you're watching a political debate, and there's a candidate whose views align very tightly with yours. And there's another candidate that has views that are very antithetical to your own views. As the debate goes on, the rules would be that the two candidates should get equal time. There's a tendency for us to believe that the other candidate, who has views very directly opposite to our own, is taking more than his or her fair share of the time, and that our candidate has been shortchanged on time. This information would certainly be consistent with our prior beliefs, our inclinations to want to favor this set of beliefs over that set of beliefs. Here's another example that comes to us from the world of athletics. Let's say that we're watching some kind of athletic game, and within the game a particular event occurs that is very ambiguous. It might have been a rules violation, it might not have been a rules violation. If you're a fan of the team that has just emitted the questionable behavior, you're inclined to believe that there really was no violation. On the other hand, if you're a member or a fan of the other team, you'd be inclined to believe that that particular behavior actually was a violation of the rule. So here, there's a tendency again to be persuaded by information that's consistent with our prior beliefs. Two people can be looking at exactly the same event and come to different conclusions because of this confirmation bias. A good exercise for you would be to attempt to generate novel and persuasive examples of confirmation biases on your own. This is a good way to actively practice the notion of confirmation bias. Okay, so we can say that a confirmation bias is a type of error, just like the heuristics tend to generate errors for us. Daniel Kahneman and others had done some work on the so-called dual processing theory. And this also leads us to understand more clearly where errors come from in our thinking, in our cognition. Let's define the dual processing theory this way. This proposes that judgments rely on two systems, one that sacrifices accuracy for speed, and one that sacrifices speed for accuracy. So-called System 1 is relatively fast but less accurate, and it's one of the two components of our dual processing theory. This is very much heuristic-based. We can contrast this with so-called System 2, which is slower but more accurate in the dual processing theory. And this is said to be algorithm-based. It's a step-by-step procedure for decisions. Algorithms are nice because they're very much guaranteed to generate a correct outcome. The problem is they're very slow, and they're also very cognitively demanding. They don't come to us easily. We have to really work at them. Recognizing, though, that there might be some benefit to an algorithmic approach to thinking, back in the ancient world, Aristotle had developed something called the syllogism as an early way to begin formalizing and putting into algorithmic format our thinking. Typically, a syllogism consists of 3 lines. It's a 3-line argument. It contains 2 premises in support of a conclusion, and our conclusion comes last. Let's take some examples of syllogisms. One syllogism might be as follows. All humans are primates. That's our first line. Our second line, all primates are animals. And here comes our conclusion. Therefore, all humans are animals. Now that syllogism contained 2 lines that were accurate as premises, and they led to support an accurate conclusion. But not all syllogisms contain true premises, and when they don't, then the conclusion is not necessarily correct. Here's an interesting alternative. It might be that the premises are actually factually correct, but they are arranged in such a way as to have invalid logic. Not all syllogisms contain valid logic. So what do we mean by valid logic? We would say that valid logic occurs when a conclusion necessarily follows from its premises. The emphasis here is on the word necessarily. Let's take a case of a 3-line syllogism that has 2 correct premises, but a conclusion that is both incorrect and certainly doesn't follow from its premises. So here we go. Line 1, all humans are primates. Line 2, all dogs are mammals. Conclusion, therefore all dogs are primates. Well, the first 2 premises were correct, but they didn't line up to give us a conclusion that follows of necessity. In fact, the conclusion was actually incorrect. So the fact that we have a 3-line structure and that the 3rd line is preceded by the word therefore does not guarantee that we're generating a valid form of reasoning. Syllogisms that contain true premises and also valid logic are said to be sound. It would behoove us then to find a couple of different formats for syllogisms that always generate valid logic and hopefully then are sound if we also have true premises. Let's take 2 examples, again from the ancient world. One syllogistic format that always generates a correct outcome is said to be the format known as modus tollens. Modus tollens can be defined the following way. A valid form of reasoning that arises from denying the consequent. So here we have some terminology that we'll have to unpack. To understand the consequent, let's first contrast that with something called the antecedent, and this is the first portion of a proposition. Antecedent means to come first, or to come before. We can contrast that with the consequent, and this is what comes later, the last portion of a proposition. So here then is the format of modus tollens. If P is true, then Q is true. That's our first statement. If we were to do an empirical analysis and find out that Q is not true, we could therefore conclude that P is not true. So we might state it this way. If P, then Q, not Q, therefore not P. Let's take a very specific example where the letter P will correspond to the state of raining, and the letter Q will correspond to a wet street. So let's take a look at this and say that if it's raining, then the street will be wet. If we do an empirical investigation and find out that the street is not wet, we can therefore conclude that it is not raining. If P, then Q, not Q, therefore not P. Here's another example. If a student is P, pregnant, then that student is Q, female. If the student is not female, then the student is not pregnant. That's a valid form of reasoning using modus tollens. Notice here that what we've done is we've denied the consequent. We've shown through negation that Q, in this case, is not true. And having done that, that allows us to conclude that P, the antecedent, is not true. And this is a valid form of reasoning. Okay, let's go on to another kind of format that again is like a syllogism because it contains 3 lines and there are 2 premises that are going to work to support the third line, which will be the conclusion. This, though, is not called modus tollens, but rather is known as modus ponens. Can we all say that together? Modus ponens. And here we have a valid form of reasoning, just like modus tollens was, but now this is arising from affirming the antecedent. Again, the antecedent would be the first portion of a proposition, and the consequent would be the second portion of the proposition. So if P is true, then Q is true. We can affirm the antecedent here, and having affirmed the antecedent, the laws of logic allow us to conclude that Q is true. So if it rains, then the street is wet. It rains, P, therefore Q, the street is wet. This is not a particularly exciting form of logic, but it is one that is valid. If P, then Q, P, therefore Q. Going back to our earlier example, if the student is pregnant, P, then the student is female, Q. The student is pregnant, as we've been able to confirm through some kind of empirical analysis. Therefore, we can fairly conclude, Q, that the student is female. Notice that when we contrast modus tollens and modus ponens, one involves negation, and it is specifically the negation of the consequent, not the negation of the antecedent. Modus ponens involves affirmation, but we specifically affirm the antecedent, not the consequent. Thanks for listening.